solve a calculus problem about atmospheric pressure. So the problem is the following. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, 1.0332227 kilograms per square centimeter. The table shows the pressure, P in atmospheres, at selected altitudes, H in kilometers. So the graph we have to solve is the following. And we are asked to solve the following linear equation. P, so pressure equals A plus B, L, N, H. This is a function we have to put in a graphing utility, and it will give us an error. So the question is, why does it give us an error? The answer is because the first value of H is 0. So Ln 0, it's equal to error because we can't have an ln of 0. Here is the example that it gives us an error.
The second question asks us to graph the function h equals a plus b ln p. That means that we're going to put the values of p on h and the values of h on p. Here is an evidence on how we graph it. We put the values of p on x and the values of h on y. And this is not an error. Here is the graph.
Well, basically as a team, we concluded that we already finally identified the error. Our error was in this first row of the pressure. There are the numbers 0 and 1. And the question is why this is the error in this chart. It's because ln never can be number 0. ln can never have a value of 0. So after plotting the numbers on Via Graphematica, there are the numbers without the 0 and 1. That was our first row. We concluded that our equation was y equals 1.0531 minus 0.3324 ln of x. We concluded that this is the equation we are gonna be basing all of our values since now. And well, when we substitute all, after making the process of substituting in the x value all of our numbers that are labeled in this chart, we could go to the conclusion via Graphematica that the attitude of our graph and line is as we want it, and we got to our objective, making to a conclusion that the error was 0 to 1 and it wasn't necessary on our chart values. Okay, well, now we are gonna solve the letter D and letter E from our problem, and we can see here how they say use the model to estimate the altitude when P equals 0.75. We already know that P can be also substituted as our Y value. So this is our equation that we are going to use to get our letter D solved. And we already make the substitution via Graphematica, where we can see that 0.75 is our Y, and our final answer is 2.4889.
Letter E of the problem asks us to estimate the pressure when the altitude is 13. The altitude in our problem is x, so we put the 13 on x, and we're going to estimate the pressure. And we did it also via Graphematica. When the x is 13, the y is 0.2. That means that when the altitude is 13, the pressure is 0.20. The last question of the problem asks us to find the rate of change when the altitude is 5 and 20. So we need to find the rate of change of the pressure, and that means that we need to find the derivative of our equation. Our equation is y equals 1.0531 minus 0.3324 ln x. So if we derivate this, y prime equals, this is 0, and the derivative of this is 0.3324 minus 0.3324, 1 over x, because the derivative of ln of x is 1 over x. So the derivative is 0.3324 over x. They ask us to replace the x, the h, our h, with 5 and 20, so we replace it, and y prime of 5 equals minus 0.3324 over 5, and that gives us a value of minus 0.06, and then we need to substitute the x with the value of 20 to find the pressure when the altitude is 20, the rate of change. So it's minus 0.3324 over 20, that is negative 0.01 when the pressure, the rate of pressure, the rate of change of pressure when the altitude is 20. So that's the end of our problem, finding the derivative of this equation and substituting the altitude to find the rate of change of the pressure.
So this team project we had helped us to apply all the knowledge we have got through the course of calculus. So using our knowledge and using as a resource Graphmatica, we found out some new things that were not exactly what we knew before. So we want to thank everyone who watches this video for your attention, and we hope you also understood the error we found out on this equation, and that this video is helpful for you to understand this topic. Thank you very much.